My name is Nimrod. I work for Wix. And we'll be talking about Spray, which is, in their words, it's an open source toolkit for building REST HTTP-based integration layers on top of Scala and Akka. Basically, it's a web framework. Well, it's not exactly a framework because they didn't want it to be a framework at all. They wanted to be really, really light. And we'll talk about why that is. But first of all, let's talk about why do we need another HTTP framework at all? I suppose everybody here used an HTTP layer of some kind at some point, right? So we have all these things that we know and love and used, Netty and servlets and Play framework and all that. So why do we need another one? These work. These work well. These are proven out in the field. Why would I need another framework? And can't we use this one? Sure we can. But do we want to? Is it good enough? And I think as people who use Scala, that the answer isn't as simple as I've used it, it works. There are other things I want. I'm a Scala developer, so I'm very picky. So here's what I don't want. I don't want that. And I don't want a container. Today it's very, very popular not to use containers anymore. Definitely don't want XML. But there's other stuff that I don't want. I don't want mutability. And I don't want Java to be there under the surface, because what happens in a lot of frameworks is that you get, even if you get a Scala DSL, then very soon you get to the Java stuff where you need to import conversions and those kind of things where you have to start moving to Java back and forth. And I don't want that either. And I don't want it to be a framework. I want it to be very thin. The reason is that frameworks tend to, as Uncle Bob Martin likes to say, frameworks are out to get you. They want you to derive from their classes. Hey, you want to use me? Just use my classes and derive from them, and then you're hooked, and it's done, and you can't get rid of them for the rest of your life and the application's life, and you're stuck with it forever. And if one day you realize that there's something better and newer out there, then you can't use it. So I want it to be very thin, something that I can put on the edge of my application, and if I want to switch it to something else, I can do it easily. I want it to be testable. A lot of these frameworks are very hard to test. And usually what I'd have to do is write a big end-to-end test that brings up the server and brings everything up with it and send requests with some client, and it takes a long time. And I want my tests to be fast, and I want to have a lot of them. Doing E2Es is too long. I want something else. And I want Scala because I want case classes and function values, and I want the collection framework from Scala, not from Java, because that's more powerful. And most importantly, I want type safety. And I'm not talking about the actual usage. I want it in my XMLs, in my routing. And I might want this as well. Although this is, Akka is you know, controversial. Some people love it, some people don't like it. For any of us who want to do a lot of concurrency, Akka is a very good answer to doing very complicated stuff. Because, face it, we're not very good at writing concurrent code. We suck at it because it's complicated, and there isn't an amount of synchronization that we know how to do well. And the actor model is something that gives us an abstraction over this, where we can reason about concurrency in a simple way, where it actually makes sense, and let the Akka people deal with all the locks and everything underneath, and we can just write our software. Plus, it gives out all kinds of other neat stuff, like I don't have to manage my own thread pools, and I don't need to manage my logging and my configuration and all that stuff. I have Akka, it does everything for me. It's almost a container, but I can switch it if I want to. Spray uses Scala. It's written in Scala down to the bottom, and it uses Akka, which is also written in Scala, down to Java and IO. And it uses actors and futures, so everything's concurrent and everything's asynchronous and everything is non-blocking. That's great. The new Akka IO used to be Spray IO, and now it's integrated into it. There's a lot going into Akka from Spray. We'll talk about that. And again, because I have Akka underneath, then I don't need to manage all these things. I have Akka doing my heavy lifting for me. So Spray has some main modules. It has a server DSL, that's a high-level language that's very easy to construct and very nice to work with. We'll see it in a moment. There's a client DSL that I won't be talking about today because I doubt I have the time. Maybe we'll mention a couple stuff. They both run on a low-level HTTP server client implementation, which is called SprayCan. It's very fast. They have a whole HTTP data model, which is completely mutable, and it's based on case classes, which we like. And it has a great test kit, which we'll show. And it allows me to test my server without actually activating it. Well, not all the way. So what is Spray routing? Let's start with the canonical hello world. So this is a root. A root is just a value. We'll talk about what's going on here in a minute, but basically I send a message to hello and I expect to get world back. But of course this won't work on itself. I need to add this stuff. So it's not perfect, but this can be done once. So this is okay. And basically even this isn't that bad if I'll explain it to you. This is basically just an app, a Scala app with my service is my own trait that has this thing in it. A simple routing app is something that Spray gives you, but you don't really have to use it. You can just use an actor. And basically, I just need an actor system from Akka. If you're familiar with it, it's just the basic aggregator of dispatchers and thread pools and everything that Akka manages. That's the actor system. You have one per system. And then I want to start my own web server. I can also use containers. They have a nice servlet connector where Spray runs on top of a servlet engine. But if I don't want even that, and that's great, then I can just use this thing, and it's fast, and it's nice, and it's agile. I just run start server with my root in the end, and it will run on localhost with whatever port I need. And there's all kinds of configuration. You can put it there, but it's not really important. The important stuff is this thing. This is my root. And a root is just a function. It's a type alias from a request context to nothing. Because when I handle an HTTP request, I'm doing mutation. I'm changing whatever the response is going to be. I'm writing into the response object. That's been the world ever since the whole thing was created, and that's fine. But how do I work with it is really nice. I can do it. The simplest thing would be to just take my context and just complete it. And complete is a function that can get a lot of things, but the simplest thing is just a string. And it will return the response. I can also get rid of this ugliness and just do it this way, where I run a function that does this behind the scenes, but my DSL becomes really neat. But this is like the simplest root that I can get. And the one thing I really want to do with roots is compose them. I want to do different things. I want to change them and bend them and have some of them respond to what goes on with the requests. And I want to call from one to the other. And this is the basic stuff that I want to do with them. I want to transform them. I want to change whatever the request has and give it to another root and tell it, this has a parameter that the request didn't have originally. Or change the response when the whole thing comes back, because I don't want an inner root to know about something that goes out in the root that contains it. I want to filter requests for certain roots, like for an HTTP method. This root can only handle gets or posts. It only handles whatever starts with API, or it needs a certain parameter like a session ID. And the last thing, of course, is root chaining. I want to chain roots. Well, chaining is a kind of a Spray word. Basically, I want to have different roots where if something didn't work, I want to try something else. If my first root expected a path parameter and it didn't get it, then maybe my second one will. And this is all composed by something called directives. We saw these directives at the beginning with path. Path is a directive. It's a filtering directive. And it says, only answer those requests that have this path. And it can also transform, and it can do value extraction, and it can do request completion, which is the complete that we saw. These are all directives. And a directive is an object that has some really convenient functions on them. And the simplest one composes roots one with another. And it uses this really small thing that is a bit hard to read, and I hope they change it. But basically, if this is my root, and I have a hierarchy of paths, for example, then this is my API, and these are the requests going to some subfolder. And this is the first one that actually does something. And then if that doesn't work or doesn't fit, then I use the second one. And if this whole thing didn't work, then I use this one. And the tilde concatenates them into a large root that can answer all of these types of requests. The question was, when this happens, does the request get matched on the root, or does it actually try it? The answer is yes, it is matched, of course. It doesn't actually do what's inside, because what you do inside happens in the complete. If you reach the complete, it'll work. And we'll see it right now. This is a simple filtering directive. There are two filters here. One is the path. So this root will be called if path begins with hello. And it has to be a get message. And once I've gone through these two filters, then the complete will be activated and world will be returned. The same goes here. If I'm in hi and it's a post, then complete will be called. And what happens if I call hi with a get? This will get rejected by this path, and this will get rejected by the post. This should immediately raise you a small red light that will say the order matters. What gets checked first is very important, because if I switch these around, then requests might go in where I didn't want them to. So this is kind of a sensitive area. Once you get something working, it's very easy to extract it to something that is reusable, and we'll see that in a sec. The question was is it an or else or a parser function? No, it's not exactly either of those. What happens inside is that there is actually a data structure that is constructed when this happens, and it just goes. It tries the first one, see if it gets a rejection, which we'll talk about, then it goes back out, and then it tries to see if it got a response, then it just returns it. If it got a rejection, it gets the next one in the list. This kind of composes a list, a tree, really. So what's the difference between this complete and this complete? Because you say the syntax is a bit different. In Scala, you can exchange a single parameter function with a parenthesis to a brace, and it's exactly the same. This isn't a space thing. It's a Scala thing. The question was, can path have other things in it? Of course it can, because we're talking about REST, and REST has to have parameters in it. So this path contains an integer after student, and I'm getting the integer here in this ID. This is called an extractor. And then I can use it inside my complete, because this is just a function. The nice thing about this is that this is type safe. If I get a root, if I get a directive path that I'm expecting an int number in it, and I don't try to extract ID from it, this will not compile. And another last thing I can do is I can compose directives one with another and create new directives on my own. For example, I can create the directive get or post by getting or posting. Or is defined on a directive, and it allows me to match a directive if either of those matches, and then I can use it in my root. And what I'm doing here with the ampersand is I'm requiring both of these to match. So it has to be a path test, and it has to be a get or a post. And then it will complete.
How is that, the and, different from the nested syntax we said before?
It's not. This gives you a way to just minimize the whole thing. Usually the first reaction to something like this is that this is very long. This is very verbose. But I can get the same thing done with this. And the nice thing about these little snippets is that I can reuse this anywhere I want in my program. So if I create a path with a variable that is something that is reused in my program, it's very easy to not write that code again. Here I have a path that is constructed of subpaths. So if a teacher teaches a course and I want to get the teacher number and the course number, then I can put these into variables, into values, and then construct the teacher course value path. And then my root can use that as the directive and get a tuple with both values in it. And then I can use that in my complete. But what happens if I have my get or post? I want to use my teacher course with the get or post. And I get the same thing again. So it has to have both of these variables. Without them, it won't compile. And the matching goes, it has to have a teacher, and then an integer, and then a course, and then an integer, and it has to be a get or a post. But look at this code is really small. So all I have to do is prepare these in advance, and I get something which is very lean. And again, I can compose that even further. If this is something that repeats itself, I can just go, okay, so get or post teacher course is just those two together, and I can use a directive like this. And again, type safety plays a very big role here because these identifiers, the functions or and are type safe, which means, can anybody guess why this won't compile? Yes, get doesn't get a parameter. So I can't or on two things that don't match. And there are many variations of directives that come in built in with Spray. For example, the parameter one, because if I don't want my parameters to be in the path, I can just send request parameters. It's very easy to get them out. I just ask for a param and I turn it into an int. If it's not an int, I'll get a rejection and not an exception. And I can use param just like before. I can do validation inside my path, which is inside my root, which is very comfortable for small validations, for things that aren't very complicated. And if they are, I can always write functions and then pass those in. This just accepts a function that returns a Boolean, and then some error message, which can also be something that you construct from whatever you want. This doesn't have to be a string. It can be like a full request, a full HTTP response. And if it gets the parameter and passes validation, only then will the complete run. And it can use the param because it's an int, and I can use it and it's type safe. So what are those rejections that I keep mentioning? The way that directives work and roots work is that whenever a root doesn't match, I get a rejection of some type. There is a whole subtree of rejections. Generally, Spray has a general rejection handler, which will basically send something appropriate. If it's a method that didn't match to anything, you'll get bad method, and you'll get some generic error. And a lot of that stuff. But usually what you want to do is write your own. And there are two ways to do it. One of them is this. I create my own rejection handler. This specific case is one of the ugly cases of Spray, where nil, or the empty list, is what happens when no page is found. This is a 404. So yeah, this is kind of ugly. I hope this is something they change in the next version. But in any case, I can, instead of throwing out something that I don't control, I can complete it with my not found, which is a 404, and some message or whatever I want. And again, if I use my get or post teacher course, I can put in a definition of the handle rejections around my complete or around any directive that I put. And if any of the directives inside the handle rejections throw out a rejection that this particular one knows how to handle, then it will be activated. But the nice thing about it is that it's selective. It can choose which kind of rejections it handles. It doesn't have to handle everything. I can choose that I have a general rejection handler that handles some things that are called on everything. And this is implicit, so I don't have to attach it to everything. I just define it before my route is constructed. And then whenever I activate something and it's missing a query param with an ID, then something like this gets sent back to the client. And you can choose which kind of rejections you use, because this is a list of rejections, and well, it's not exactly this function literal on rejection is a bit misleading, but this it knows how to find my specific one inside the list. So if I get a missing query param rejection, then this will be completed, and if not, then it just doesn't do anything. And this goes for this one as well. If my rejection isn't a not found, then this won't do anything, and it'll just go bubbling up to the general rejection handler. And if it doesn't use mine, then it'll use sprays, which handles everything. Spray also works very well with the synchrony, because as we've said several times, we use Akka. And Akka is great for asynchrony. We just send stuff to actors. And this is especially important in the case of Spray, because each request is handled by an actor, and each route is handled by the same actor. This is the problem because an actor is single-threaded. So if I'm going to do blocking calculations inside my actor, this will kill my application. But it can be easily solved by sending my requests to another actor. And spinning up actors is very, very cheap, and I can spin millions of them within very small amounts of memory. So if I have an actor that does some kind of calculation, I can easily, in my path, send a message to that calculator and expect an answer. This isn't the best way to do it, because this is the ask function. Yeah, this is in Akka you're trying to usually tell things like this. You want to tell somebody, this is fire and forget, and this is expect a future. And this, although it doesn't block, it spins up another actor that waits behind the scenes for that response to return. So this is expensive, but it's doable. If this doesn't happen very often, I can definitely do this. It's non-blocking. It will be sent. I'll get an answer at some point. And the nice thing about it is you don't see a future anywhere in here, because complete hides it from me. It knows how to handle futures on its own. The test kit that they wrote has support for Specs2 and Scala test. And the nice thing about it is you don't need to spin up the server. I don't need to run up the server. I don't need a Jetty. I don't need anything. All I need is the actor system, because I'm running on Akka, and everything's on actors. But an actor system is not a very expensive thing to spin up, and actors are very, very cheap, so it's fast. So every test in the test kit looks like this. It's a request, some kind of a get or a post or whatever I want. It looks very similar to the way the client works. Then I give it a route, which will be my route that I'm trying to test. Then the keyword check, and then assertions. And this is what it looks like. So this is a Specs2 specification. I mix in a Specs2 root test, which is a trait that gives me all of these lovely things. And I mix in my own trait that defines my root. That way I can use the same one in my tests and in my production code, and I don't have to do copying stupid things, and I can just share everything and actually test what I'm writing. The only thing that I wish they will change is that because my service is an HTTP service, which is a spray trait, it needs an access to the actor system, and this is the only way it knows. I have to give it the definition of the system, and it's kind of weird because it's there because of their own traits. I mean, I didn't get it from the sky. I got it from the Specs2 root tests. So I'm not sure why I have to define it again, but it doesn't work without it. So in a simple spec, I do a GET request to my server. It's very comfortable that I don't have to go all localhost and ports and that kind of stuff. I don't care. Nothing's running. There is no server. I just want to unit test my roots, not end-to-end test. And this just spins up the actor that gets the requests, and it sends the request objects directly to it. So there is no listener, there is no socket listening on anything. So I'm sending a request directly to my root, and I'm checking the response. And the response, in this case, when I'm transforming into a string, needs to be world. The same thing goes for rejections. I can check that once I send a post to my root for hello, which only accepts get, I'm supposed to get a rejection. And I'm supposed to get a method rejection, which means the method I used isn't supported, and which one is supported. Rejection is a construct you get from Specs2, which pretty much says, take the response. It's a function that takes a response and pulls out the rejection for you. So they have a lot of these, like status and body and whatever. There's pretty much anything you'd want. Here's status. I want to check that the status is method not allowed. What happens here is that I'm getting a rejection back, but I don't know what kind of an HTTP response my client will get once the rejection will be thrown. Well, not exactly thrown, returned, because it's not an exception. By the way, I didn't mention it before, there's also a handle exception handler, which does exactly the same thing as a rejection, but it knows how to catch certain exceptions. So you can catch whatever exceptions you want in a partial function and handle those you want, and if you don't want to, you can let spray handle it. So the difference is I want to know what gets actually returned to the client, and this doesn't tell me. This gives me a method rejection. So the way to do it is to seal the root. A seal root function covers the root itself with another layer that, given a rejection, turns it into a response, and it knows how to transform the rejection into an HTTP response that spray returns, and I can check on that all of the little attributes that I get, what the status was, what the message is, those kind of things. So a bit about the future of a spray. Spray's been around for a while, and about a year ago, maybe more, the ACA people took a lot of interest in it. And what happened was that at first they took Spray's I/O layer, which is a really low-level Java NIO layer that is very fast, and they just ported it straight into ACA and enhanced it, and now ACA I/O is Spray I/O with steroids. And both those teams are working together, and the future is bright because I don't know how many of you are following ACA stuff, but they announced their reactive streams not very long ago, which is that the whole trend from TypeSafe is going very, very reactive, and Akka is on the forefront. And they announced about, I think it's like 5 months ago, maybe less, Akka HTTP, which was in beta a long time. I think the first version is out, and it's basically Spray 2. And what they're doing is they're taking a lot of these APIs, especially the client, and polishing them even further to make them smaller, to make them even more composable. They're adding Java APIs for those of us who like Java, none of us. And it's based on reactive streams, which means that you get a lot of the reactivity that some of it is a bit clunky in Spray. Chunk messages are a bit clunky in Spray. It is possible. It's not hard, but it requires getting a lot of messages in your actors. There's a start chunk and then an end chunk, and there's chunks in the middle, and you have to operate on them. It's not the best DSL that they wrote. This is getting completely overworked in Akka. The client gets completely changed. They're adding WebSockets support, which isn't supported out of the box in Spray, but there's more than one plugin that does it. I think if you just search Spray and WebSockets on GitHub, then you get, I think there's 3 or 4 of them now. And you can do it, but it's not the most rewarding experience. Well, this is already out. A lot of this is experimental, especially the client stuff is still very experimental. You can use it. They have, I think it's milestone 2 or 3 now. So version 1 is out. But the whole Akka streams and Akka HTTP is still in the experimental stage. So if you use it, it will change a lot. So early adopters, welcome. But anybody else, I'd wait a bit. The question was, is everything's changing? So no, not everything is changing. The server is staying pretty much the same. They were enhancing it a lot with Akka streams because streaming in the Spray right now is clunky, so they're changing that. I know they're adding a lot of the Akka streams itself into it, so there's going to be a lot of new directives. But the client is getting completely overhauled, so Spray client is probably going to die in like a version or 2. I think Akka HTTP is still in an experimental stage. So if you're going into a production system that needs to be there for a while, I'd still go for Spray. I think if you use Spray as the server, making the change to Akka HTTP once that becomes stable will be easy. For the client, I don't know what to tell you. It's gone. I mean, you can use Spray, but once it changes, you'll have to rewrite it, probably. And right now, there is no client in Akka HTTP, so you don't really have an alternative. Okay, so a bit of references. All the documentation is on Spray.io. There are very, very good examples that they made, like a whole applications with using a lot of directives and a lot of the test kits on GitHub. So if anybody want to go into this, this is a very good place to go. And this is me. And that's it.